Assalamualaikum warahmatullahi taala wabarakatuh dan selamat sejahtera. My name is Afiq Hamizan bin Syaharudin under supervision of Mr. AZRIN bin AHMAD and Mr. Mohamed FIRDAUS bin HUSSIN. Today I would like to present about extraction of hydroxyapatite using heat decomposition of fish byproduct for biomedical application. The presentation outline starting with introduction, objective and scope, problem statement, literature review, research methodology, result and discussion, and lastly conclusion and recommendation. For introduction, background of study, hydroxyapatite or HA is a source of calcium for teeth and important compound to repair a bone. HA are a more suitable based on physiological condition. High bioactivity, high compatibility, and non-toxicity. The annual demand of fish increase every year. The need of fish has led to abundant fish waste. For application of HA is have application for biomedical bone repair. Second, human bone implant material. Third, scaffold for tissue engineering. In fish, we can get a carbonate HA, water, type 1 collagen, and non-collagenous protein. After that, we move to objective and scope. There are three objectives, which is one, to analyze the potential of fish bone for bone tissue regeneration using bibliometric study. Second, to prepare a natural hydroxyapatite from fish byproduct towards hydroxyapatite production. And last objective is to characterize the hydroxyapatite using SRD, SEM, EDS, and FTIR analysis. For scope of study, 1. Literature study on the past journal in the Scopus database to observe the trend about the research by using bibliometric study. Then the data will be generated with both viewer software. Second, the sardine or Sardinella longiceps fish bone need to be cleaned with tap water and boil it for 1 hour with temperature of 100 degrees Celsius. Number 3, dry the fish bone in electric oven for 24 hours and calcinate the fish bone for 5 hours with temperature of 700 degrees. And lastly, to analyze the calcinate fish bone powder with X-ray diffraction analysis (SRD), scanning electron microscope (SEM), and energy dispersive X-ray spectroscopy (EDS), and lastly for Fourier transform infrared spectroscopy (FTIR). Okay, for the problem statement, first, to change the old method, which is bone graft. Bone graft are very expensive and time consuming because bone graft are taking other part of the bone in the human body and replace it to the broken bone. Second, limited supply of natural bone. For bone replacement, there are growing needs for synthetic bone to replace a bone. Third, incorporate byproduct and waste from the fish bone waste as alternative in obtain HA. Last, to overcome the religion issues, which is Muslim and Hindu community for HA production. There are 4 methods to synthesis HA, which is dry method, wet method, hydrothermal, and combination method. For literature review, it is a search of evaluation of availability literature review that I summarize it that related to my study. Starting with bibliometric study, hydroxyapatite, method of synthesis HA, and sardine, Sardinella longiceps. For research methodology, the preparation of fish bone powder. The raw material was obtained from Platinum Marine Product Lumut in Perak, Malaysia. After that, the fish bone was cleaned and washed with tap water. to remove flesh, blood, and skin. Then proceed with boiling for 1 hour to remove excessive protein, limbs, oil, and other organic contamination. After that, for drying process set to 100 degrees Celsius for 24 hours to remove flesh, smell, and moisture. After that, place it to the medium size crucible. Then proceed with calcination process. Calcination process are set to 700 degrees Celsius for 5 hours. After that, the calcinate fish bone are crushed with mortar and pestle. After that, we use a filter floor to get a calcinate powder. For result and discussion, bibliometric study the trend in the number of the publication between 2010 until 2020 based on the keywords research in Scopus database and analysis by using bibliometric study found that the keyword of hydroxyapatite with those specific subkey which is bone and teeth. The data seems to keep going and increasing by year based on figure 1. Okay, this is the collaboration between country on hydroxyapatite between 2010 until 2020 was generated by both viewer software. Hydroxyapatite result. Starting with the SRD analysis pattern, the SRD pattern of calcinate fishbone which is sardine with temperature of 700 degrees Celsius for 5 hours. In this observation, the crystalline of hydroxyapatite show the characteristic peak at 695, 674, 2336, 2009, 604, 883, 580, and 603. Additional, the SRD pattern of the sample show the hydroxyapatite and calcium oxide but no presence of beta tritium phosphate. For the second analysis, which is FTIR analysis graph data, FTIR spectrum of the sample in the calcinated at 700 degrees Celsius for 5 hours, the sardine fishbone present in figure 4, the sample show the series of usual of phosphate ion, carbonate ion, and hydroxide ion. The intensity of hydroxide stretching band are due to amount of water absorption on the porous surface of HA sample. Okay, next, for SEM magnification analysis. For visual microstructure analysis of hydroxyapatite powder, magnification of times 19, times 7,000, and times 10,000 were used in figure 5. The microstructure of the powder particle is very tiny and practically spherical in shape. According to the visual inspection, the average particle of the hydroxyapatite powder made from discard fishbone was found to be 300 nm or nanometer. Accordingly, as the result of the organic material decomposition, the calcinate bone has had many pores or holes. It is obvious that the increasing of calcination temperature resulting in increasing of particle size. Okay, for the last analysis, which is EDS analysis, EDS analysis table data based on table 1 by using EDS analysis, the main element of all sample are calcium and phosphorus with an average of CAP, molar ratio about 1.2 by using equation 1. Equation 1 which is atomic calcium percent divided with atomic phosphorus percent. This ratio is lower than the amount of stoichiometric 1 of 1.67 in human body. The CAP ratio may be influenced by the amount of Mg, Na, C, and O element in calcinated fish bone. In conclusion, the bibliometric study for the past 10 years to analyze the past data. Hydroxyapatite extraction in Scopus database between 2010 until 2020 shows the upward trend and increasing by years for this research. Second, sardine bone can be the alternative source to obtain the hydroxyapatite. Sardine bone also can replace bovine and porcine bone on producing the hydroxyapatite. Last, since the fish bone produces the hydroxyapatite which is biomaterial good for biomedical application, the environmental pollution caused by the fish waste can be overcome for good. For recommendation for this research, 1. To analyze the fish bone with a different temperature such as 600 degrees Celsius, 700 degrees Celsius, 800 until 1000 degrees Celsius to analyze more deeply on elemental reaction. Second, use ceramic furnace to perform calcination process for hydroxyapatite extraction to avoid elemental reaction in the furnace. Third, use pneumatic sieving for such as MAJSX micro air jet sieve to obtain accurate and finer particle size for easiest characterized process for hydroxyapatite. Last, using KBr, which is potassium bromide on specimen during FTIR analysis, because FTIR window using all KBr crystal when the IR measurement through the specimen, the IR will only analyze the specimen and entering the KBR. So, thank you.